This video is in response to a question from section 8.1 in the book, which is sampling distributions of sample means. This is problem number 7. So the question was asking how to know which method to use to solve a problem. And I do want to say that sometimes there is more than one method to solve these problems. So for instance, the way I'm going to show this is not the way the book says to do it. So at least not to start out. So here we are. I'm going to tell you my process. So the reading speed of second grade students in a large city is approximately normal. So that's important. That tells us that we are looking at a normal probability distribution. So I immediately have the vision of the normal curve in my head. It has the reading speed mean is 89 words per minute, and it has a standard deviation of 10 words per minute. And so it says to complete parts A through F, and the first part asks about the probability a randomly selected student in the city will read more than 94 words per minute. So that, to me, is a normal probability distribution. So I open up StatCrunch, and we're going to do our stat calculators normal. And since they gave us the mean and the standard deviation, I'm just going to type it in. Mean, standard deviation, and I want to know the probability that they will read more than 94 words per minute. So that's the probability, 0.3085. Okay, so that's the way I did that problem. If you look at the example and what they say in the example, they tell you to do a standard normal probability distribution. Now, a standardized normal, you just take, all you're doing is taking the normal curve and standardizing it where the mean is 0 and a standard deviation is 1. And then the z-score tells you how far from the mean you are in relation to the number of standard deviations away, which is completely valid, but in this case unnecessary to do it that way. So there are times when you're comparing between two different scenarios and you want to have the means and the standard deviations where you can compare them, then making a standardized normal is super important. So now to interpret this probability, again, this is the probability you can also think of as a percentage. So 30.85% of the randomly selected students would have be able to read more than 94 words a minute. So when you're reading this, if 100 different students were chosen from this population, we would expect them to read more than, it needs to match, 31. So let's look at part B. Part B asks for the probability that a random sample of 13 second grade students results in a mean reading rate of more than 94 words per minute. So we want to know about the probability for a random sample having a specific mean. And so this is actually based on the sampling distribution of sample means. And so we need to do a little bit of work to be able to figure this out. First of all, when we're doing this sample distribution of sample means, we have to figure out a new mean and a new standard deviation because we need the standard deviation of the sampling distribution, which is also called the standard error of the mean. So the mean for a sampling distribution of sample means is equal to the mean of the original. So for that one, that's 89. But for the standard error of the mean, we take our standard deviation, which was 10, and we divide it by the square root of n, which is the square root of 13. So let's take our calculator out and take our standard deviation and divide it by the square root of 13. And we get 2.7735. So we're going to still use the normal curve because sampling distribution of sample means is by definition normal. So we're still going to use our normal curve, but we're going to use a different standard deviation. So the mean is the same as the population mean, and the standard deviation is not standard deviation anymore. It's the standard error of the mean, which is 2.7735. And then I want to know about the probability there. And so in general, our standard deviation of sample means is going to be closer to our mean value because it has a smaller standard error from the mean. And so the probability that it's going to have something further distance away from the mean, it's going to have a smaller probability. That's what we would expect, and that's what we see. So it's 0.0357 for this second part. And again, when we interpret, we'd expect them to have more. And we multiply this number by 100 and round. And then here, a random sample of 26 second grade students. So this is again the same problem as B, but we have to define a new standard error of the mean because this is a different sample size than in part B. So I believe that's enough to get you through the rest of this problem. Please let me know if you have any other questions.